Hi guys, this is one more problem from section 3.1. This is number 19. So this one is actually a nice one also because the idea here is something we didn't use in the last two videos. We're just like one step of integration by parts kind of helped us in the last two problem, I guess number 11 and 17. But in this one actually we're going to have to do two application of integration by parts, okay? But that's actually a nice one because sometimes people get to the first stage by parts and then they think they give up because they think it's not going to get easier. Well, here's the thing. I've been telling you, I guess, last couple of videos that when you do integration by parts, once your integral on the right become worse than the one on the left, of course, that tells you made some wrong choices for your u and dv. But this is a case where the integral on the right actually doesn't become much worse, or it doesn't become worse, it actually becomes very similar. So this is why on this one, we'll do two doses of integration by parts, and that should take care of it, okay? And by the way, usually when you have e to the x and sine and cosine involved, this phenomena usually happens, okay? So there may be some other homework you can try and see if you get the idea. So we have integral of e to the x, sine of x dx, okay? So again, in this case, I think you can probably do it both ways. You can let u be this, and then that to be dv, or you can let u be that to be dv. I think either way, it does work out the same way. Or at least it works similarly, okay? So I'm going to go ahead and again, don't forget our formula. By parts, the integral of u dv is uv minus integral of v du, okay? So we're just going to start by letting u be e to the x. And of course, that would force dv to be obviously sine x dx. Okay? So now if u is e to the x, du of course will be simply derivative of e to the x, which is e to the x. Don't forget dx. And then of course to find v from dv, we're going to integrate dv to get the v, which of course becomes integral of sine x dx. As you know, integral of sine is negative cosine, because the derivative of cosine is negative sine, so integral of sine becomes negative cosine. Okay, so there's your v. Now we're going to go up here. So this is our u dv, which by the formula says equals u, which is e to the x, and then times v, which in this case becomes negative cos. I'll rewrite it later. Right now I'm just going to write everything the way it is. And then minus, here comes again the moment of truth. Don't forget, if this integral becomes worse than what you start with, obviously that tells you you made some wrong choices. But this one won't be worse, but it'll be very similar. And that's why these types of problem, you do two doses of integration by parts, that should work. And that is equal to integral of v, which of course is negative cosine, and then times du, which of course becomes e to the x dx. So as you can see, this has almost the same nature. I mean, if you kind of ignore the negative, of course, here we had e to the x sine x. This is e to the x cosine x. So it didn't really get much worse. It's almost the same, similar idea. So that, I mean, there may still be a hope. We may be able to compute our integral, okay? But I'm going to go ahead and rewrite this a little bit better. So I'm going to put the negative to the front. So that becomes minus e to the x cosine x. Minus times minus become plus, and then integral of cosine x e to the x dx. Okay? So let me just make sure you can see that. All right, so I'm going to pause for a minute. So again, don't forget, we start with this integral, right? So from here, we use integration by parts. So from here, we have this integral to be this. Well, this much is already done. So now the question is, what is this integral? Well, here's the idea. This integral itself has to be, again, done by integration by parts. So that's why I said in this problem, you do two doses of integration by parts, okay? So I'm going to go ahead and leave this actually down here. But I'm going to show you real quick what this is going to be again with the similar idea, integration by parts. That way, and then, of course, we'll come back and put it all together, okay? But for now, I'm just going to pause for a minute. So I'm just going to do this one by itself. So the integral of cosine x e to the x dx, again, by using, I'm just going to go ahead and give you the u and dv, because you're going to go through the same idea here. So for this one, we're going to let, again, u be e to the x, and of course dv to be cosine x dx. So du, of course, again, is going to be e to the x dx. And the v, here is what you're about to see here, which is very nice. Integral of cosine x dx, which, of course, let me take this off. I guess I can take this one off too. So now, integral of cosine, of course, simply becomes sine x dx. Okay, so remember now, this I'm just doing this part right here, which is part of our original integral, an integral of cosine x e to the x dx. Now we can do a by parts formula, which becomes u, which is e to the x, times v, which is simply sine x. Oops, sorry, there is no dx here. Sine x, and then minus. Now here's what the beauty is about to happen here. Okay, just gonna move this out of the way. Minus, now remember the formula, minus integral of v. What is our v in this case? Sine of x. And then, of course, du, which is simply e to the x dx. Now, what do you notice? Well, what you notice, I hope, is that this integral that came from our second integration by parts is actually exactly the same as the original integral you started with, okay? And anytime that happens, that means you're now actually ready to compute that. So let me go ahead and, so this integral right here became this, right? I'm just going to box this. So this was the same as our integral of cosine, right? But remember, our original integral is this plus that. So I'm going to go ahead and, so remember, all of this work was just to do this second part. So we did that. There we have it. So now I'm just going to take this off. So now we should be able to hopefully do our original integral. So remember, that integral turned out to be the same as this part, which is negative e to the x cosine x. And then plus this integral, which we got to be this, which is going to be e to the x sine x, and then minus integral of sine x e to the x dx. Okay, so now I'm going to actually, just to make it more clear, I'm going to go ahead and write down the actual integral. So remember, this is all of that. So now we have integral of e to the x sine x dx equals to that. But what do you notice? These are the same. So I'm going to go ahead and try to get them all to the same side. Then we can isolate it. So we're going to go ahead and add the same integral to both sides. Integral of sine x e to the x dx plus integral of sine x. By the way, e to the x sine is same as sine e to the x. So I'm sure that doesn't confuse anybody there. So as you add that, well, 1 plus 1 becomes 2. So now you have 2 integral of sine x e to the x dx equals, so those two, of course, cancel. And then you have the same thing, negative e to the x, negative e to the x cosine x, and then, of course, plus e to the x sine x. Okay, so now, finally, we can isolate this by dividing both sides by 2. I'm going to go ahead and take this off. So now if you divide both sides by 2, you should have your original integral evaluated, okay? So from here, the 2 cancel. So now we have finally, remember, this was our original integral, e to the x sine x, or sine x e to the x, doesn't really matter. I'm going to write it as the original way. E to the x sine x dx becomes simply, I'm going to put that 1/2 to the front, and then time. Actually, you can actually factor e to the x if you want. It's not an option. And as you factor e to the x also, that leaves you with a negative cosine, and then plus sine. You can also stick your c at the end. Plus your c, the constant of integration, only you worry about that at the very end of your integral, okay? Make sure you can see that. Okay, so there is your integral, okay? So this was a case where actually we did 2 application of integration by parts. But remember, once we got our second integral, it didn't get uglier. It was almost the same type of integral. That's why there was hope for us to continue. And then finally, we were able to isolate the original integral in one side and then have the result on the other side, okay? All right.